Welcome to our presentation. My name is Chris Walkowitz. I'm a machine vision expert with Datalogic, and I'm really excited to share with you an automotive inspection that's running right now on the factory floor. Before I jump into the actual application, I want to share with you the hardware that we've been using. So it's an MSeries processor, which is a multi-camera processor, and when I say multi-camera, it's a processor that can actually accept cameras of high resolution, cameras of different form factors, and cameras of different sizes. Also, this processor is a multi-core processor and is extremely fast at processing images. Ultimately, you're able to get very high production speeds from a device like this. I hear time and time again from our customers that anytime you need more than one camera, the M-Series is ultimately the lowest cost option. The reason is because you can select different brands of cameras and one processor. There's really no excessive hardware needed. Ultimately, it leads to the lowest cost solution. Also, the M-Series processor has a built-in PC, so a user can program the cameras, they can create an interface, and operators can interact with the cameras during runtime, all from this one device. There's no separate PC needed. I do want to point out that this PC is a really nice PC. It's an industrial PC. It's made to handle the conditions of the factory floor. So let's jump into that application. Here we have an automotive valve manufacturing cell. There's one vision processor and 4 cameras. And you can see the user interface is right on the front of this machine. Here's a look inside that manufacturing cell. The top camera's doing an orifice measurement. The middle cameras looking for the part orientation, and the bottom 2 cameras are looking to see if the O-rings are in the correct position and that they're seated properly on the part. So here's the orifice measurement. We're simply looking for the area of the orifice. Here's the part orientation camera, and we're simply looking to see if that narrow part of the part is facing left or the narrow part is facing right. If it's facing left, it's a pass. If it's facing right, it's a fail. And I do want to point out that these parts are flying by extremely quickly. The O-ring cameras work together to make sure the O-ring is in place, and if either camera detects an O-ring that is bad, the part is rejected. These cameras actually trigger at the exact same time and work together to make a decision as to whether it's passing or failing. The processor, which I showed you earlier in that picture, is actually hung up inside this controls cabinet on a DIN rail. This processor is really cool because it's actually made to sit inside normal controls cabinets. The HMI is simply a monitor which can be obtained from any type of computer. It's just a regular PC monitor. Same with the mouse and keyboard, and those devices are plugged right into that processor. So why did our partner choose the M-Series for this machine? Well, they had one machine and they just wanted one single vision system. They wanted one point of interaction. Also, they had a need for multiple inspections. The M-Series achieves this perfectly. They had a need for a camera that can, or a system that can handle very high frame rates and very fast processing. Perfect for the M-Series. Ultimately, it was the lowest cost option. So let's get into the software. I'm going to be showing you Impact VPM software, which is used to program the cameras, and Impact CPM software, which is used to create an interface for the cameras, which will allow users to interact with the cameras during runtime. So let's jump into VPM right now. Okay, so I'm now in VPM, which stands for Vision Program Manager, and I'm going to show you how to create an application to inspect the size of this hole. So the first thing we're going to do is go into our feature finding toolbox, and we're going to drop out a tool called the blob tool, which is essentially going to look for white pixels in this image. We're going to go to our setup screens on the right. I'm going to click on ROI, which stands for region of interest, and you can see as I move this ROI over the image, pixels that it's looking for are highlighted. I actually want to look for bright pixels, so I'm going to change that in this drop-down menu here. And instead of trying to fit this over the entire image, I'm going to go ahead and delete it by clicking the X on the left, and now it's going to look at the entire image. I'm now going to go to my next setup screen and set the PassFail criteria. So I can see the area of all the pixels, or the area of all the touching pixels, which is called a blob. is 126,601. I know that this first image is actually a failing orifice image. The hole is too small. The actual dimensions, or the actual area, is supposed to be 127,000. And that's the minimum. I'm going to go ahead and set the maximum at 132,000. And I know this just by running some parts through and testing good versus bad parts. And I'm going to come down to the bottom and I'm going to say I must have at least one blob or one set of pixels grouped together that matches this criteria. If I have more than one or less than one, it's a fail. And in this case, since this blob does not meet this criteria, I have 0 blobs, which is displayed right here, that matches criteria. Let's go ahead and test out our tool. So you can see this orifice is passing because the area is within the minimum and maximum boundaries. Here's a number of other orifices that were shot with our camera during this inspection. Let's go ahead and add in a little bit of logic. I'm going to add in a PassFail tool, which allows different branches of execution of the program. And if there's a failing part, I actually want the program to execute down the fail branch. So I'm going to add in a communication tool, which is going to be just a discrete output, which essentially is an electrical pulse to some rejection device that's going to kick this part off the line. I'm going to come into this tool and I'm going to say, if there's a reject, I want to pulse output 1 for 200 milliseconds, and that's going to kick the part off the production line. And that's our application for the orifice inspection. Okay, I've now connected up to our second camera, and I'm going to check the orientation of this part. And the way I'm going to do it is by measuring the left half of the part, and if the left half is narrow, like you see in the image here, it's a pass. If it's tall, it means it's facing the wrong direction and it's a fail. So the first thing we need to do is we need to locate the part, because the part's going to move within that image. So I'm going to go to the locating toolbox, pick the origin tool, and drag it out into the program. I'm going to go to the ROI screen, and we're going to just choose the default, which is the most common ROI configuration that we're going to use here. I'm then going to go to the pass-fail screen, and I'm going to adjust these ROIs, or regions of interest. And the first two ROIs, I'm going to adjust to look for the conveyor line. I'm going to set them both to look for dark pixels. And you can see as I do that, they're going to find the first dark edge as they look from the tip of the arrow to the head of the arrow. I'm then going to adjust this perpendicular ROI, so it's actually perpendicular to those two. Set it to dark, and you can see it found 2 points here and a point here and created this yellow crosshairs, which is what we call the origin. Let's snap through a few images and you can watch that origin move with the part. Looks good. I think it's working properly. So let's go ahead and add a measurement tool in now. I'm going to come to the measurement toolbox. I'm going to choose line gauge, dual ROI. There are a number of measurement tools we could use to achieve the correct measurement here, but this one is as good as any, and it's one of my favorite tools. It's so simple to set up. So we're going to come to the setup screen. I'm going to adjust these two ROIs. The blue one I'm going to put on the conveyor. The yellow one I'm going to put on the top of the part. I'm going to say look for dark edges. I'm going to come into the next step, and you can see it's measuring from point to point. But really, I want it to measure from the top of this part down to this red line, which is the bottom of the conveyor. So I'm going to choose absolute Y. And now you can see I'm just measuring from the top of the part to the bottom of the conveyor. Let's go ahead and set up some pass-fail criteria. So I know that this part is 0.5 inches. So I'm going to type that in, and I'm going to take the units from pixels to inches. So I'm going to type in 0.5 and hit train. I'm now going to set my tolerances to 0.5 minus 0.25, so we can have a large minus side because it can get smaller, and that's okay, and plus of 0.05. And I think that should do it, and we may have to tweak it, and that's pretty normal, but I don't want it to get much taller than this. So let's go ahead and try this out. Okay, so there's a failing part. The wide side is facing to the left, and you can see from the screen that everything's red, indicating failure. Good. Narrow side's left, that's good. And again, the wide side is facing left, so that's a failure. Great, this inspection looks good. I'm going to go ahead and add in the pass-fail logic just like before, and then we'll go in to camera 3. So let's go ahead and add that in. Alright, I'm now on my third camera, and I'm going to go ahead and set up the inspection to look for the O-ring on the top of this part. And the O-ring is located right here where I'm pointing my mouse. And what we're going to do is use one of the tools called the Pinpoint Pattern Find tool. This is probably one of the most useful and most powerful tools within our software and within the industry as a whole. So I'm going to go under the Locating toolbox, and I'm going to choose Pinpoint Pattern Find, drag that out into the program. And it's really simple to set up. I'm simply going to train this region of interest, or I'm actually going to train two regions of interest. So I'm going to take this one, I'm going to hit copy, and I'm going to place it on both sides of the part, and I really want to look to see where this O-ring is positioned on the part. I'm going to say that O-ring can rotate a few degrees, that's just fine. And a little bit of scaling, it could get slightly bigger, slightly smaller. And I'm going to say the way I'm training it should be slightly less sensitive because it's a pretty straightforward part. I'm then going to hit the train button, and here's the pattern that it trained on. So now I'm going to come into the search screen, and I know that the O-ring should always be approximately in this position on the part. And I'm going to position this green ROI so it's outside of the noisy region on the left and on the right side of the image. I'm then going to say we need a minimum score or a minimum pattern matching score of 90. And let's go ahead and test it out. So there's a bad part, it's missing the O-ring. You can see the score is below the threshold, and thus we have a failing part. Good part. A couple more failing parts you saw. You can see the O-rings are falling off the bottom. Same there. And this inspection is ready to be deployed. So let's go ahead and add in the pass-fail logic, just like before. And we have an application that is ready to be deployed. Okay, I'm now in our program called Impact CPM, which stands for Control Panel Manager. And CPM is a program that's used to create an interface which allows users to interact with the cameras. So maybe the users want to see the images that are going through at the moment. Maybe they want to adjust the tolerances on a measurement. That can all be done from this interface. So let's go ahead and build one. First thing I'm going to do is drop in an image. So I drag it from the program to the interface, and you'll see the image come up here in a second. And for demonstration purposes, I'm going to drop in this special trigger tool. Normally, a trigger tool would not be added. However, in this case, we're going to have one because we need to trigger the camera manually. Like I say, normally it wouldn't be added because a sensor would be triggering the camera from the production line. This would not typically be a manual process. So let's go ahead and test the interface. This is what the users would see minus the toolbar during production. And we are triggering the camera. Great. Let's go in and add a little bit more detail. I'm going to come into the Pattern Find tool. I'm going to put those pattern points onto the image. I'm now going to come down to the Pass-Fail tool. Let me go ahead and minimize this so we have a little more space to see what's happening. I'm going to put the passing state out onto the image. I'm going to connect it to those points so we can turn these dots red or green to indicate pass or fail. Let's also go ahead and drop in an indicator light so it's very clear whether this is pass or fail. Let's also add a pass count, fail count, and run count. It's always nice to view statistics about your manufacturing process. Let's go ahead and add a label. So pass count. Fail count. And run count. And let's go ahead and close this toolbox. And let's add a reset button so we can reset those counters. Great, and let's test this system out. We'll trigger the camera a few times. Looks like it's working properly. And let's try resetting the counters. And that also works. So you can notice this interface is not just used for viewing what's going on in the camera, but you can also interact with the camera and make changes to the camera. And in a normal application, we would display all 4 cameras on this control panel so you can see what's going on with the entire system. But for this demonstration, I just wanted to show you how to set one up. In a minute, I'll show you what a final application or a final CPM deployment might look like. Alright, and what I'm showing you here is a screenshot of CPM actually deployed. And what I want to point out is multiple cameras on one interface. So someone could walk up and they could quickly see how their production's running. They can get statistics, they can reset counters, they can train parts, they can adjust tolerances. Basically anything you want to adjust with the cameras can be done from CPM. And this is a totally customizable interface. And it's a really cool program. I really enjoy using it. It's a lot of fun. Well, that wraps up our presentation. Before I go, I want to thank MPC of Prairie du Chien, Wisconsin. They supplied us with images and photos of their machines, so thank you to them. They really went above and beyond in helping us with this. And I want to thank you for watching. Again, my name was Chris Walkowitz. Thank you, and have a great day.